actually, my name is Thomas, and one of the reasons, or like one of the decisions I had to make when I was asked to do a keynote is actually to talk about something trendy, AI, like data with AI, something like that, something that would look cool on LinkedIn, right? And then maybe it makes sense to talk about something that we have to deal each day. And here I am talking about technical debt. And about the technical debt, every one of us have some code in production that makes us cringe. Like if you don't, you're lying to yourself. And that's actually okay. And why it's okay, you think about it. I'm Thomas, very tons of links, whatnot. You can scan the QR, connect with me. I've been doing data for 13 years. And yesterday I was asked actually when I started coding, I was like thinking professionally, but actually first lines of my code were written in 99. I'm that old. But I'm not here to talk about myself. I'm here to talk about actually the technical debt. So first thing first, and the most important, is to get our vocabulary straight, right? If we don't have the same definition, we're gonna have trouble aligning our expectations and how we're moving forward. So for this simple thing, I actually have three quick definitions. So one of them is the shortcuts you take that will cost you later, right? It's a quick example is that when you have leakage in your house, you have to fix it now, right? It doesn't matter, is it important because water leakage is compared to wallpaper change. Wallpaper change is just a cosmetical thing and that you can live with it. It doesn't create any urgency and you can just leave it until you have either funds or when you feel like it. Or maybe you find a good color of the wallpaper if you like. Then there's the second one is a more theoretical. It's any gap you have in your current system and where you wish it was. So mostly it's just the distance between today's system and your today's understanding. Personally, for me, those two definitions are kind of because they're hard to explain to business. And the most important of them is actually what matters. So, matters only that depth that's slowing you down or actually costing money. Because, for the business, it doesn't matter if you're saying something is not right, we have to fix some technical debt, then understand it via monetary value, right? If you can prove it that we're burning money, it's not efficient, we have to fix it. And let's go about this. I'm gonna be honest, I'm no saint, I have tons of code that I have now created or have left for someone else to take care of. We have so many spaghetti code there. Like if you don't, like I envy you, but I have doubts, that you're maybe lying to yourself, right? So let's start with the simple one. There's a simple, maybe not that simple pipeline that I wrote somewhere in 2018. It's running fine. If I would look at it today, most likely I would write it way differently, way more efficiently, I guess. But it's not something crucial. That one, I can compare to a wallpaper change at my home. If you have, of course, wallpapers. If you have like painted walls, you can leave it and forget about it. No one used it, or like no one had the need to use it, so it can stay and we can forget about it. The next one is that the notorious, something temporary that's been dubbed one source of truth. I guess there's nothing more permanent than a temporary solution. Interesting thing about this one is it was some intermediary table I created along the way and had a suffix at the end, underscore TMP. It could have had delete me later or whatnot, but some people discovered it and oh, it makes sense. I have to use it. Then they contacted me why it's dropped. I'm like, it was a temporary part, I'm just dropping things along the way, cleaning up. And they're like, can you leave it? We're using it, in our core process. Like, okay, I left the company. Now that permanent is someone else's problem. Oh well. And the most thing I'm not proud of. When I'm saying 1,000, mostly it's like 4 or 5,000 lines. And I'm not exaggerating. We had very interesting flows where some specific calculations that had to be done, and it was one of my most complex, I guess, solutions during that time, like when I was mostly starting, and it was super complicated. I was thinking like, can I simplify it? Okay, I'll split into multiple smaller tables, then convoluted logic somewhere here, somewhere there. And after I left, I contacted some people who were working still there, and they said, you know what? We're like 2 years in trying to rewrite it, but somehow the numbers doesn't match. I'm like, okay, not my problem. Dodge the bullet there. I guess you can see all of those three kind of fall into different categories, right? And if you're following um, like Uncle Bob, Martin Fowler, uh, you can have, or like you can remember the arguments about how they differentiated the technical depth. So Uncle Bob has a well-known take on this, is that if a code was written by people not knowing what they're doing, it's kind of not a technical depth, right? They made a decision with the knowledge they have. But in my eyes, it's a bit more complicated than that. And when I found Fowler's article about technical depth, it kind of resonated with me because, you know, you're making choices with like either you're doing deliberately some things, either you're actually like recklessly doing some things, and it's all about the choices. If you didn't know better, did you learn from it or did you do it differently? So let's start, with the depth quadrant of Fowler. So he gave us two questions, right? Is it reckless or it was prudent? Meaning basically if you cut corners or you didn't know that corners they actually exist, right? That's one. Second one is like if your choice was deliberate or inadvertent, meaning basically that were you taking this depth or you actually figured it out later, right? Basically, did you learn something out of it? Two questions, right? Simply two axes, and that gives you four kinds of depth, right? The key insight here, the right side of this, the prudent part, is a good depth. The problem is with the reckless choices you make along the way. So, reckless and deliberate. Someone said, let's do it this way. You didn't question. You made that choice, even if it's wrong, even if your gut feeling is saying it's wrong, but you just did it. Good design actually makes you faster, and cutting corners sometimes bites you in the ass very, very fast. So, next one is under the reckless and inadvertent. It's basically when I mentioned, are you cutting corners? Or you didn't even know that those corners actually exist, right? Is what you actually do. If it's a gap of knowledge and what you're doing this. And for me, personally, the all good depth, like I mentioned before, is in the prudent or in the right side. And this is the good use of depth because you know what you're doing, what's the trade off, and what depth you have to deal with later. So it's actually fine. It's how most of the best teams should work. And the only problem with this, you register that this is a technical depth and you don't get back to it. You leave it somewhere, you forget about it. So that's the biggest problem with this one. And then we have prudent and inadvertent. This one sounds strange, right? How can it be prudent and inadvertent? But basically, it's when you actually figure out things along the way that you did wrongly, that you made mistakes, that you actually cut corners and whatnot. So it's not like you did something wrong, you just didn't know how to do it better, and you're going to do it better next time. And can you guess on which part of this quadrants actually most of the teams are? Like raise your hands if it's on the prudent and inadvertent. No. Prudent and deliberate. No. Reckless and inadvertent. No. Yay, if you didn't raise your hands. Everyone lives here mostly, right? And that's the question, right? So why do we live there? And I think we're actually we're kind of creating technical debt for ourselves. If you think about it, it's not because the trade-offs, because we actually write it off as we don't have time, to do it properly. Like that's I will deal with it later. Um, that's the default answer, right? If you ask your developers, to like, why did you do this? We didn't have time to fix this. We didn't have time to think about it, and it's kind of annoying, right? So for me, why it matters from those four actually categorizes uh, what kind of debt it is. The problem is, how you're gonna deal with that tech debt, right? It's not the one thing, like choosing one debt or another. It's how you're actually dealing with it, and this is the part I kept coming back. Um, do I have to fix all my technical debt? Do I care about it all? And I guess the answer is no. Not all of it is equal, right? Some of it you have to fix fast. With some of it, you can ignore it and just forget about it. Some of it you have to plan and actually strategize for. So, mostly, I figured like what tech debt gives you. It gives you pain, right? You have to, when you have to deal with that tech debt, you have either low pain or you don't care, right? Because you don't have to work around that fast. You don't have to think about solutions, how to solve it later, whatnot. And then you have the high pain, like in order to, I don't know, let's say deploy something, you have to do five manual steps, or in order to increase your cluster, instead of having in Terraform or whatnot, you just have to manually do the click ops, and raise everything. And it's kind of important, right? The pain. But when you think about it, there's another axis, which is also important, and the cost, how much it would cost you to actually fix it. So again, two axes, and we have four types of debt, or like one is the quick wins. Basically, it's very costly for you to deal with, but to fix it, super easy, super simple. Cheap fixes, or like what we love to say, quick wins for the management. When you do it, your developers are more happy. Management kind of doesn't notice, and you don't even have to wait for the next sprint. Then there is a strategic projects where you actually have to plan and prioritize. Those actually involve coordination between multiple teams. Maybe there are some system impacts, some connections that you have to figure out before, or like someone is using your API without you knowing that they're using. So you have to ensure that everything is running smoothly. So you have to scope them, you have to budget them, you have to plan them in advance, and most of them actually are taking like not a couple of weeks, they take months to implement and to do. Now this one is which I like most, the leave it alone part. Seriously, if you have a highly costly technical debt that gives you an hour of inconvenience, leave it alone, please. Usually what falls here is ego driven, I guess, things that you don't like, the certain aesthetics of code, you don't like the layout, but it's not bad. It works, right? And if you would have to rewrite, it would take you months, of time to do it. This is the problem where most of us developers fall through, because our ego is broken, right? We're like, what the are we doing this? This is nonsense. We have to fix it. And this is where the most mistakes happen. You spend tons of time rewriting it. No one notices. You don't sometimes even have any improvements. And you're doing some trade offs along the way. That also ends up in the leave it alone pile. And then you actually come back to it and think, like, do they actually need to do it? So that's the third one. And the most, actually, the easiest one is the nice to haves. So basically, here falls very short, like simple things that are a bit annoying. You have to, it's not hard to fix them or do them. So those actually can be very good onboarding tasks for your team. Like if a newcomer is joining, for him to actually know your code base, your processes, and some of them, uh, and basically improve your quality of life, people will know your code base better, and you're gonna have a better time. But let's go with this. Like I guess about the excitement part, I'm gonna go with all the mistakes I made along the way. So story one, it was basically experience when we had one big migration, and we had clear pain points. It's I guess the harder part of it was to quantify, the return on investment, and this is the basic. We know it hurts. We can't justify it. So let's start with we had multiple separate environments. We didn't have a dev environment. Casual one, like this part is keeps haunting me because usually when I come to a company, no one has dev environment because everyone works in prod. I guess that's how real development is done. Uh, Jokes aside, right? Some of the pipelines were running slower. That was just because of like differences in the engines and how Redshift works. Um, it was, I guess, fine, when you had less data, you had less pipelines running. But then, when you move forward, you have like more data coming in, more historical data. Your complexity of your SQL queries actually like increases, and everything bottles up, right? And you get stuck. Then you have delays, and those kind of things. And what happened there is that it was like a long project. I think it took like 10 to 12 months to complete. But then you might ask, what's the outcome of it, right? If you migrated it, right? What was the benefits? So first of all, simple starts, you do a dev env, right? Simple, stupid. Then you consolidate, right? You don't have to run around, through different environments, think what to do where and so on. Less cognitive load, simpler things for everyone. Kind of cost reduction was like I taken it from the air, be honest. Looked like it, and it was easy to scale. If you worked with Snowflake, increasing the size of it is like instantaneous. And kind of financial case made it a bit easier. Though if you would look forward, like if you would be forward thinking, it didn't happen right away after you migrated because there's a fundamental difference on how the data is stored, how it's worked with, and so on. So you have to slowly, work into it, adjust your storage tactics, like maybe cluster on different things and functionality. But the most important things, what we had, happy engineers. Happy engineers are very good engineers. Then you try to look for other lazy solutions for them to do, because in my eyes, the best engineers are lazy ones because they try to optimize and do less work. I guess it's quite good, in this age of AI. But if you remember those 4 quadrants, right? Quick wins, strategic projects, leave it alone, and nice to haves. Which one do you think this one fit? Yes, strategic. So it was high pain, high cost. We had to, synergize with other departments, figure out their usages and fix it. Another one, loving this one. This one's for the books. When you actually, where I was wrong. Oh my, I was wrong. Surprising. So, like, long story short, when I was working in one company, basically we had some like strange pipeline. It was written in pig. Who even knows what's pig? One hand. Yeah, I didn't know as well. And then, like the task came in and like, you know what? Maybe this weekly process can be done, on a daily basis. Like me, full enthusiastic and young and stupid, decided actually, let's rewrite it in something new and fancy, So processing was done once a week. Could have just changed the schedule. Code was written in pig, super annoying. Worked without failures. Completely. Didn't fail once. And then you're like, let's rewrite it. So this one, didn't take that long, not 10 to 12 months. Me not knowing anything took me like 4 6 weeks to figure out how pig works, how it's connected to everything, what's Apache Spark, how to write simple things with it. And let's go to this. I learned pig. As one hand was risen, you can see how it was useful for me in my entire career, to learn that one language. Nice and shiny. I rewrote it in Spark, knew some internals. It was fun. It was cleaner code, zero business impact. But you know what's the biggest takeaway? It got deprecated. That's the best one, right? You're doing stuff for 4 to 6 weeks. You're trying, your best. It didn't cost you money, actually. You weren't losing anything. You didn't gain anything, speed wise, or like data wise, and your whole work went to shit, let's say, right? Because it just got deprecated. And I wish I knew this quote sooner. Don't remember from who, but working code that's ugly is often better than perfect code that took forever to build, right? That's the key takeaway for any of you who are trying to do perfect pipelines, clean everything up and so on. Good enough is good enough. If it works, it doesn't bother you, leave it, right? And can you guess which one this belonged to? Yeah, it's kind of debatable, it's either don't touch it or nice to have. Like 4 to 6 weeks, not that high cost of like someone, coming in, but if it would be a senior spending time, it would be actually highly cost. And it doesn't actually make sense. So I'm going to take a short water break because I guess my throat is a bit choking. So since I'm talking about stories, and sharing, my experiences, let's go with a third one. This one is, by the way, not related to the first story. That's one of the reasons why I said, that having no dev was kind of following me always. So we have self-managed Airflow. Who's working with Airflow? If you're interested, come to my talk in the afternoon where I'm gonna talk more about these things. Shameless plug. So we thought about moving to a managed version of Airflow to actually have some wins, more flexibility, do some things faster. Actually, we had some issues, doing this, but we can talk about it in the afternoon. And basically, we had quite interesting setup. It was Airflow, where everything is running in different Docker containers and was connected. But Docker on Docker, not the best way how to run it. No dev environment, like I mentioned, kind of common practice, or I'm a magnet maybe to such places. We have residue of Docker images where basically Docker image gets built, then our storage is getting piled up with new image. Then suddenly something crashes, we have some downtime, then you have to know where to log in, we don't have any documentation, the classic story. And we didn't have any infrastructure as code. So basically we had one guy, or like maybe two, who knew things. And how can do this? It's only pure ClickOps. As I mentioned, no documentation. You have to know which network to choose, what are the settings, all the firewall stuff. It's a bit complicated when you're working in a smaller team, and it kind of creates a need for you to have a very, knowledgeable or very diverse team, but you don't have actually the need for it, right? Why you have to self-manage this environment if it's not that beneficial for you? So one of the reasons what we decided is that let's reduce the cognitive load for us and let's migrate, right? So yeah, we have single managed environment. We have we have dev environment as well, and we actually created some CI/CD for our flows. This allowed us actually to have tests. All the code was deployed automatically with the checks. We got alerts. We have auto scaling mostly because nothing comes without a price. But about this also in the afternoon talk. We have better monitoring, alerting, right? Because we can actually check CloudWatch to figure out what's going wrong, if everything is working properly, and so on. But you know what? We traded old debt for new. What happened? Worker auto scaling actually bottlenecks during peak hours because that's how managed version of Airflow works on AWS, right? It takes some time for new workers to spin up. So that's pile up. You suddenly have like, I think I saw a peak of like 200 tasks in queue. That was fun. But eventually, it goes down. So we traded for that. Another one is since you're running on managed one, right? You're kind of limited to the resources you get there. You don't have much control. You cannot say, oh, run this on like more RAM, right? You cannot have this on this, right? Everything is running on the same infrastructure, and you have to deal with them. So what we did, we actually thought of like, let's do some workarounds. Let's do smaller batches, maybe split in a bit different way without having to deal with OOMs because they're basically very annoying. So main moral of this: migrating away from debt doesn't mean you're debt free. You're just trading one kind of set for another, right? Point here is, do you know which tech debt you're trading for what, right? What you're gonna do with it as well. So I think the point of this is how to decide if this debt needs fixing and how to deal with it. Right? For me, I'm gonna try to walk you like 5 questions, I guess, with which can help you decide. So before you go and refactor, walk yourself through each of those questions. So one, is it actually causing pain? Right? I remember that our developer egos are very easily hurt, right? We see tabs instead of spaces, we get hurt. We see spaces instead of tabs, we get hurt. Oh, you're using, different naming standard than me, we get hurt. Does it actually cause you pain or just annoyed, right? If you're annoyed, forget about it. You have more fun things to do in your life, right? Than to actually be ego hurt. Can you measure the cost? Right, very easily. As I mentioned, one of the things that business understands: how much money you're burning, how much money you're actually not delivering, and whatnot. It can be developer time, it can be, I don't know, infra cost along the time, how you're spending, and if you're actually fixing some things, how much it will save you, and so on. What's the opportunity cost, right? Because sometimes dealing with tech debt, you're delaying some features to be rolled out for your customers, right? And you have to choose, right? What would be more beneficial for your company or for even you, maybe? Then will that debt will get worse over time? Because like you might say, like, isn't the all debt same? Answer is no, actually. And if we're talking about this, we have 2 different types of debt. One is the stable one ugly function, like I mentioned, some ugly flow that no one is touching, no one cares about. It's always going to be the same, right? You don't just, you can live with it, forget about it, ignore, doesn't matter. And then there's one that's actually annoying, and its cost will grow over time. So, like, very simple reasons, right? Missing tests, missing documentation, inconsistent patterns, and I don't know, those things spread like wildfire actually, because some of our code are just copy pasted, some of it, we have to patch over, find all the places where it's used and what. So the thing, or the main takeaway here, is fix compounding debt early, especially if it's cheap now. Otherwise, you're gonna do a full rewrite, and your small fix you could have made a year ago evolves into some huge project, that you have to deal for a year or so, right? So keep in mind about if your debt stays worse or stable. And the most important one: can you get the stakeholder buy-in? This is, I think, the problem where most of us fail, unfortunately. And one of the reasons, like I mentioned, we don't speak usually the same language as the stakeholders, you know. And this is the part where actually I want to talk and help you understand what they understand. One of the reasons, like why I'm mentioning, dollars and how they understand it, is that that's how they operate, right? They're everyone is trying to bring more revenue, more users. So how do we translate our technical debt, or like the need to fix the technical debt for the stakeholders? What doesn't work if you're saying, "Oh, this code is messy, it's annoying." No one cares. Like the PMs or POs, they don't look at your code; they're looking at the end output. If it works, it works on my machine, right? I don't care about it. We need to refactor. If you don't have like some good arguments or like measurements, right? Why you need to do this, it won't work. It's not following the best practices. So what? It works. We can focus on the features, right? And trust me, bro, it's important. That's the best one. No one will actually care if you say, "Trust me, I need to fix this." No, that's not gonna work. What works, you transfer these to dollars very easily. Transfer it to dollars. This costs us X in compute. If we do this, it will save us like, I don't know, 1K a month or whatnot. That you can actually measure, the impact of your change. Engineers spend 5 hours a week on workarounds. So now they can actually do the count, oh, I have 4 engineers in my team, they spend 5 hours a week. So that's basically 20 hours a week on average. Then I take the average salary of that person, and actually I have dollars. Very simply, people love money. It's blocking the feature you want next month or like next quarter. Now they actually have to think like, do we need that feature next quarter, or it can wait till next year? What we can do with, right? It's not them for you to prioritize, like either this or that, right? It's for them to choose. And now they're on that dilemma. It's not you, right? You just have to raise it. And we have free production incidents. Well, everyone loves postmortems, right? And like the question is what we do with the at the end, action steps to prevent this from happening. How many of you actually follow through those steps? Yay. The thing is that's how we live, right? The real risk isn't the technical depth itself here, right? It's the problem here is with all the traps we actually fall in while working with that. So let's talk about 4 fun traps I've seen teams fall into, and some of them actually I've been in like a couple times even. So first one is the perfection trap, right? You'd actually try to do everything very, very perfectly, right? If it's not perfect, I cannot ship. The reality of this is you're never gonna deliver perfect code, right? If you're gonna look at your code like that you wrote 2 weeks or a month ago, you're gonna complain about it, right? It sucks, right? No? It's just me? Okay, so the thing is that cleaning up, like, or delivering a fully fledged clean solution actually doesn't exist in real world. You actually have to do some adjustments and trade-offs in order to not to fall into this trap. The next one is the shiny object trap. Data people, you're mostly falling into this part. Oh, they released a new framework. Let's go this. Oh, there's X framework rolling out. Oh, this framework rolling out. Let's try this, let's try that. I know that some of the innovation actually happens when you do these gambles, right? Because each of those checks actually is a gamble. If we were yesterday in the presentation by PG about the Git and is it relevant, he mentioned that GitHub made a gamble, right? It chose to stick with Git and deliver everything around, right? They did a gamble, so sometimes it works, but I guess like 8 times of 10 it doesn't, right? It doesn't stick, and you end up with constant migrations. You migrate from one framework to another. How many of you have done migration within a year? Within 2 years? Like, I envy you guys. because usually it's like, oh, new tech, new tech, new tech, and you have to just figure out what not to do. Like I guess with AI it's a bit easier, but still annoying, right? Because the tech evolves faster than you can change socks in a way. Like new releases coming like every day or whatnot. So expect some of your bets fail. Try to experiment to figure out if it's actually needed. The ignore it trap. This is the best one, where everyone says like, it's working fine, we can just leave it alone, and suddenly you have I don't know 5 different compounding debts that makes you just scrap everything and rewrite for a year. The problem here is that when these things go sideways, it happens always on the same day. Compounding debt doesn't respect your schedule. It just happens. Suddenly some production incident and like 5 more just happened because of you didn't fix something, like I don't know, a week ago. And we have the death march trap. Let's fix everything. That's when I fall in, like most of the times. But I guess I learn things as I go, and I do hope that you actually don't fall into these categories and think that good enough is good enough. So I would be a crappy keynote speaker if I wouldn't talk about AI, right? And just because 2026, let's talk about tech debt in the age of AI, right? Uh, AI actually changes everything. Right? For you to fix your technical debt, cost goes down. Yeah, because AI tools are like very good on making your refactoring cheaper. They can make your legacy code or like understanding of legacy code way faster. You can go into your code base, figure out inconsistent patterns, or like explain some methods here and there. Just drop that 5,000 line SQL code to Claude or to Copilot, and it'll actually explain what it's doing, why it's doing, and so on. I guess maybe not entirely why, but you'll get the understanding. And generating tests. Like Mark here yesterday talked about test coverage. And actually, it's a very good place. You can generate a lot of tests, and you can know if it's good or not. You can not be afraid to touch your fragile or brittle pipelines because you'll know, that your test will catch it, right? So we don't need to be afraid of like just work on production. You can actually have everything safely tested before you create some disaster, to like at 3 a.m., which you have to wake up and fix because business needs data, like or it's monthly reporting or whatnot. You can do pattern migration at scale. I guess for me, the most easiest one is when you actually have to change some specific name of the table. You just, okay, change this to this, scans all the repository, does it in an instant. Usually, some of these things took you weeks, maybe months actually to do. Now, like most day, maybe because you don't have to figure it out, right? Just like do this, when this, simple, stupid, it works. But it all looks nice and shiny, But we have new categories of debt rising up, right? They didn't exist a couple of years ago. One is that we have tons of code that nobody actually understands, right? You have, I don't know, why does it work like that? I don't know, right? It just works. I got it. Then, the incident comes in, 3 a.m. You're waking up. Oh, I have to fix this because this and that. Like, like at 3 a.m., you're kind of, semi aware of the environment and you look at the code. What is this? You don't understand, right? That's one of type of the depth. Another one is that we just accept, always allow to do the changes on our code base and let it be. This is kind of very tightly connected with the above one, but uh, multiply it when your team is one person and when you have like 5 people just always accepting, you're gonna have very fun time dealing with your technical debt. And it works, right? But the problem is it maintainable? One of the best solutions or like advices I can actually give you here is that if you don't understand it or you can't explain it, just don't take that example. Like iterate until you can actually explain those, and AI can do that. And in the net effect, what happens? Most of those things from strategic projects move to quick wins, right? That's kind of good. But the problem is that AI tech debt usually is a bit more compounding effect, right? You didn't write, you don't understand it, and later have to deal with it. So keep in mind when you're doing blindly accepting changes or working on a code that you didn't kind of fully understand. And I guess the goal here is how can you live with debt successfully? Yes, actually you can. Very simply, document it. If you're creating some technical debt, put it somewhere. Write down why you took it. It's not glamorous work, but you still have to do it, right? It's not for someone, when you leave the company, someone has to go through the code and like, why it was written like this, right? Somewhere there is a legit reason why it was done. Or maybe, it was hidden somewhere in the to do later, right? So document it. Another one is monitor it. Like this is especially valid for when you have so-called stable debt, but it suddenly, turns out compounding debt. So you have to actually monitor your stable debt if it's actually stable, if it doesn't give you, any performance degradation or whatnot. So just because they can move in between categories, you have to know what you're looking at. Rotate ownership. This is one where most of the data teams actually fail, is that they have one tech debt expert, or like one person on the team who actually knows everything. Then suddenly he's on vacation, he's sick, he leaves the company, everything is like, I don't know, he knew, but now he's not there. What should we do next? Everything becomes a black box, right? We don't like black boxes. We have to know, how it actually operates. And review quarterly. Pain changes. Maybe it was painful, I don't know, a month, a quarter ago. Now it's like, So the point is monitor and plan. So my suggestion is actually mark your tasks and how you're operating, and try to squeeze in small bits and pieces. Uh, Solving debt also gives you a compounding effect because suddenly one fix solves some other issue along the way. So tag it, monitor it, and figure out if you have a healthy split. Do small steps, right? Small step for you, but big step for your team because they don't have to deal with it. Very simply, just do a catalog of debt. Again, nothing sexy here. Just document it. Very simply, right? You have five main columns, right? What? Basically, your technical debt that you decided to keep or do. How much pain does it actually cause you? How much cost and time uh, it actually costs you? Like how much time it will take you to fix? What type of debt it is, right? Because it's very important. If it's stable and you don't have to, like the cost is high, maybe you don't just leave it, right? And the status. For you, you have to work on this continuously because that's how you're gonna improve. And you don't need any fancy tools. Like you can do Excel, I guess, like or Google Sheets, because sometimes simple like a spreadsheet, most likely every time it beats your Jira swamp, because you don't want to look at it after like 10 minutes, right? So like I'm gonna summarize this, for who fall asleep about not sexy things. So not all technical debt needs to be paid down, right? As I mentioned, some of it you can live with it, you can ignore it, and it will be the same, right? This resonates back to my pig story when I could have left it and would be fine. Another one, measure pain and cost before refactoring, because then you will know if it's just you being offended by the aesthetics or some other things that actually are not that costly. Translate debt into business language because business understands money. They don't understand code. Budget for your debt continuously. This also adds compounding effect, and you don't have to, spend quite a lot of time. And document and monitor what you keep. This is most of the biggest place where most of us fail. We take we do some shortcuts, but we don't document it why we made it, what were we gonna do later, and we have it stockpiling, somewhere for someone accidentally to fall into. And AI lowers fixing cost, but creates new risks. So, you can try to use the matrix or try something what works more for you, but technical debt isn't a failure. It's actually a tool. So use it wisely. Questions?